Hey guys, in this video we'll be going over POE device troubleshooting. We'll be covering some of the common issues that you're likely to experience if you're working with POE devices, as well as how to get to the root cause, steps to take to really troubleshoot. So, some of the most common issues: the device will not turn on, or it does turn on but only for a split second and then turns back off. The device has power, but it doesn't have a network connection. The device randomly will turn off or will randomly reboot. Now, this last one will be a little bit difficult to identify. You'll likely have to rely upon a staff member at the particular building where the issue is occurring, because they are gonna, have hands on the device or eyes on the device for a longer duration than you're gonna have the chance to. It's kind of difficult to catch this particular one in the act. So, looking at devices will not turn on. First and foremost, you have to determine if the device is not turning on at all, or if it is just turning on for a second and then back off. An easy way to do this: look for an indicator light on the device, likely a power light, and see whenever you're pressing the power button if you see a little flicker of that, or you see it turn on and then fade back off. It's very important to determine whether it's turning on at all or not at all. It's really going to take you down two different paths in troubleshooting. Another thing to look at is if you do have a separate POE splitter, meaning it's not built into the device, is there a light on that splitter? Basically, are we getting power from the POE injector to the POE splitter? Another thing you can do for a quick test is to pull all the cables out of your POE device, hold down your power button for 10 seconds, plug everything back in, and see if you can get it to work at that point. What this is going to do is clear out every capacitor inside the device. It's going to basically start you back at square one. And you'd be surprised, something so simple, how many problems that'll actually fix. Now let's take a look at how different POE systems can be laid out. Here's one basic little setup, and this is using an external injector. You can also, of course, have a POE switch to where the power is coming from the switch. But in this particular example, we're starting here at the switch with data. We go up through our patch panel, data only. Patch panel to injector, still data only. After the injector, our line now has both power and data. So this particular device would be one that would have an internal splitter, meaning it accepts one line that comes into it, and from there it splits out the power and the data. Simple enough. Here's another example. In this example, we have both a POE injector and a POE splitter. So let's trace this one out. We have the switch here putting out data. It goes down into the injector. The injector sends both data and power on the same line. That's this blue line right here. Our green line will also have data and power, and that goes to our splitter. And this is where things get a little bit different from the last example. Instead of just having one line that goes to the POE device down here, notice that we have two. The splitter will actually split apart the data and the power. You'll likely see an Ethernet line going into the device and a DC type cable, something similar to what you'd plug a laptop in for power. Now, notice also that the POE injector in this example is in the closet, and it's actually in between the switch and the patch panel. If we go back to our previous example, we can see we have our patch panel here, we have our switch here. So in this example, our injector is actually closer to the device. It's after the patch panel. And we'll go into where this could be useful a little bit later in our video. But just keep in mind, you're pushing data and power on a smaller segment of a line. Less distance, essentially. So, couple things that I would do before really getting too deep into troubleshooting when you have a will not turn on. You want to make sure you power cycle the POE injectors and the POE switches. It's just something good to cross off the list. Typically switches that'll be a little bit more beneficial for, just because they're more complex devices. They do a little bit more, and they have a higher tendency to lock up. Another great thing to test, and before I get into this next thing, anytime you're swapping in devices, like to test another POE device like I have here, make sure you test the device beforehand on a working line. Make sure without a doubt you know the device works. You can't really use it for testing if you're not certain it works. So, big thing a lot of people tend to skip over is testing their test device. Very important. Last thing I would do for something quick would be to swap any patch cables that may be between the wall and the device, that may be between the switch and the injector and the patch panel. Anywhere you can swap one, it's something quick and easy to do. I would also, if they're not brand new patch cables coming out of a bag, out of a manufacturer wrapping, packaging, I would test them. I know it seems simple, it seems stupid. Test. Always know that the equipment, the devices, whatever you're using to test your situation to get to the core of the issue, make sure that thing works, or it won't be a very good test device. Now, if you were unable to get any device, your test devices, your original device, you can't get anything to power on after going through the previous steps, let's just rewind, take a brief pause, and go through and double check everything. Every connection is connected securely, whether that be the switch to the injector to the patch panel, the wall to the splitter, and so on. Grab one of the diagrams, grab both the diagrams. Identify which setup is closest to your setup, and then go through every connection, making sure everything is connected securely. Another thing that's typically skipped over, which can maybe make you blush if you do skip this part, make sure everything that needs power is plugged into power. And I'd maybe even test the power. Bring a cell phone charger with you. If it's a wall outlet, plug into that. Make sure you're getting power to your cell phone, just for that quick test. Typically all of us walk around with a cell phone charger, or have one at our desk or in our bag, so should be easy enough to get a hold of. But now that we have physical connections rolled out and a potential bad end user device, the POE device, rolled out, the next thing we have to look at is the POE injector itself. Or, of course, if you're using a POE switch, that switch or the port on that switch, if nothing else. But we have to roll those out. And again, you always want to use devices that you've tested, swapping them in before you can truly roll out, hey, I put in this other injector here and it's doing the same thing. It's probably not the injector. Well, did you test that injector that you're swapping in? If you tested it and it's working fine over here across the hall on this other device, you're getting plenty of power out of it, you had no issues, then I'd say maybe we can lean towards an injector. If you haven't tested it and you're having the same experience, that's not for sure then at that point. You have to test your test devices. That also goes with switches and ports on that switch. Now, after we can roll out a bad potential POE injector or POE switch, sadly the next possible cause would be the line between the patch panel and the wall. A couple things to look at here. We could look at line damage, which could be a result from construction. Maybe the line was ran poorly initially through something in the ceiling that would generate excessive heat that would damage the line, or was not pulled in a nice fashion and the line was overstretched. Any kind of damage that might have been done when the line was initially put in. Another thing to look at would be the line resistance. If you have your end-to-end resistance and you're able to measure it, if it's too high, you're not going to be able to get the wattage through. You could see the device turning on for a second, then turning off. Once the amps get too high, it kind of trips something, or it just doesn't reach the amps that it needs as different components are starting up. So that's something to definitely look at. But to be able to test for the actual damaged line, which we mentioned first, you want to have an Ethernet line tester. That's going to test all 8 wires inside that Ethernet line. You know, four pairs, 4 twisted pairs. So you have 8 lines. If any of those lines do test bad, you don't want to just say the line end to end is no good. The first thing you want to do is redo the terminations at each end and then test again. Now, if you've redone the terminations and you're still seeing, line 4, line 2, whatever it would be, would test bad, then you might be looking at rerunning that line. Just to verify that it's the equipment and not the line itself. One way to do this, and this is not as a substitute to the line tester I mentioned above. This is kind of a separate thing. This is going to kind of tell you about the distance of the line. Maybe all 8 wires are fine, they're working fine. You've redone the terminations, maybe even. Still, everything looks fine, but you can't get your device to turn on. You're getting power, you have a good injector, you have a good splitter, but you can't get your device to turn on. One way to verify that it is something to do with the line is to take all these components, and it has to be the original components or maybe components you've used for testing, but set them up in a more temporary way. Take them to the closet, plug them in directly. See if you can get them to turn on at that point. If you can, well, it's going to remove a lot of things out of the equation. If you can't, maybe we're removing the line out of the equation as far as resistance, an issue with that. So we basically got it down to it could be the supply power, it could be what's splitting the power and the data, it could be what's carrying the data and the power, and it could be the device. If you follow these steps, you should be able to get to one of the core issues, or get to what the core issue is out of those 4 or 5 different possibilities. Next, let's look at power without data. Now, if you look here on the left-hand side, we have a red X and a yellow triangle. The red X would mean that you're not getting a link. The yellow triangle typically means that you're getting a link, but you're not getting out to the gateway. A lot of times called limited connectivity. If you do have limited connectivity, or sometimes it'll say maybe no internet connection, but you look at the back of the device and you see your activity lights by your Ethernet port, either your splitter or your injector are actually providing the link, but you aren't making it back to the switch, or you're making it back to the switch just fine, but your device is misconfigured. So the first thing we want to look at here is configuration. It's simple, it's easy, and I'd say it's probably more common than some of the other issues. If your device is supposed to have a static address, a couple things you have to make sure your static settings are correct. Check your gateway, check your subnet mask, check the IP that you're using. Make sure you didn't have any typos. Make sure you didn't, just make sure everything's correct there. Another thing is to make sure that the address you're using, the IP address, is reserved within the DHCP server. Just because you're using it doesn't mean the DHCP server is going to be aware of that, and it could still hand out that same address. And then when it does, you have a conflict and your device doesn't work. So handle those 2 things first if it's a static connection. Next, if it's not a static connection or you're not really certain, make sure it's set to DHCP. That should at least allow you to make the device discoverable on the network. That should take out a couple steps there, if nothing else. Let's see. Now, if everything is configured correctly, then we have to, go back and double check everything. First, check your connections. Make sure they're secure. Patch panel to injector, injector to switch, so on and so forth. Make sure you're not missing something small and little along the way that could really, maybe you've figured out the issue. Maybe it was already the splitter, you've swapped it out, but you forgot to connect something along the way and it still doesn't look like it's working. Double check everything. Always, always, always double check. Another thing you can do is use that same Ethernet tester that we just talked about and test the patch panel to the wall. Make sure all 8 lines you're getting a signal through. And if you're not, go back and follow the steps that I gave you on the will not turn on slides and test that line. If need be, rerun the line. Another thing, you can change the switch or the switch port you're using. If you are using a POE switch, identify another port that provides POE or turn on POE for that port and test on that port. Just another real quick thing to rule out. Typically, data without power, or excuse me, power without data is easy enough to identify because you are getting a connection. You are getting at least a connection from the injector to your device. So it's a much shorter little area to look at that point. So next, let's look at probably the most difficult issue to get to the bottom of, and that's going to be device that randomly dies or randomly reboots. It's likely going to be one of the following issues, but again, it's kind of difficult. It could be a dying POE injector or a dying external splitter. Maybe they're overheating. It could be the line itself, that line between the patch panel and the wall. It either could be too long, or something else is causing the resistance in that line to be too high. It's not allowing the wattage and the amperage that's necessary for that device to get to the device. And last, it could be the supply of power to the POE injector or the POE switch. Maybe it isn't stable. Maybe even the maintenance department is testing a generator failover. And that's making it look like your device is randomly dying, but really it's just that the splitter is losing power for a split second, or maybe a couple seconds, and isn't allowing the device to come back on. After you've tried swapping out the POE injectors, POE splitters with known working units, and I have to stress that they have to be known working units, and you've also ruled out any possible supply of power issues like we discussed, things that are supplying power to the POE injector so it can put power on our lines, we have to consider the run resistance. And I've touched on this a couple times in a few of the other common problems, but we're going to get way more into it here. If you're using 24 volt passive POE, don't exceed 150 feet. You just really shouldn't. It's difficult to carry 24 volt passive any further than that, even in the best circumstances. Now, if you do have an AF compliant device and you're using 48 volts, very likely you can get up to 250 feet out of it. Another factor is the type or the grade of line. If you're using a Cat 5e or a Cat 6, they're okay. But if you can find a Cat 6a, that's actually going to offer a larger diameter internal wires. So those 8 wires, they're going to have a bigger gauge, and thus provide lower resistance and allow to carry that power further without issues. Last, it could be a lower grade wire, and I don't just mean Cat 5e to Cat 6a. Two different sets of Cat 5e may not be made the same. If you look at how much copper is actually used in the physical wire, the more copper, the higher the grade. The more aluminum, the higher the resistance. So those are a couple things to check on. If you think you boiled it down, it's not the injectors, it's not the splitters, it's not the device, it has something to do with the line, but you're able to test all 8, and all 8 wires look fine, you're very likely going to be looking at the resistance in the line. Now, instead of trying to rerun another line, maybe of the Cat 6a, one thing you can do, if you refer back to our very first diagram on how POE is kind of laid out, if you remember, our POE injector was much closer to the device there. Let's see if we can't go back up. Let me find that real quick. That is slide 4. Notice how this POE injector is so much closer to the device. That means only this little segment of wire is actually carrying both data and power. So you could have maybe up to 200 feet here, and maybe just like 5 or 6 feet here. And you could be running your 24 volt passive at that point. You will, however, need some kind of power outlet. Very likely if you're running this above a drop ceiling, somewhere above that drop ceiling that you'd be able to plug it in. So there is some complication with this, but essentially that's, if you have too high a resistance of line, either have to move the device closer, get a better grade line, or move the injector closer to the device. You don't really have a lot of options with that. So I hope you guys enjoyed this video on POE troubleshooting. If you have any questions or anything else you'd like to see, please let me know and I can make another video to cover that. Thank you and take care.